There we go. Hey, Terry. So Jada, hi, Joe, Tiffany, Austin, Azad, Ozma, Mike.
How you doing, Nate?
I'm doing good. What are y'all doing? Wait, Tiffany. Tiffany has a cat. Joe, are you talking about
The
Tiffany
cat
wants?
behind you.
You got a cat behind you too, Nate?
There is 110% a cat behind you.
We gotta talk about Tiffany's cat first, though. Oh, she can't hear us. That's why. Are you blowing into his ears? Tiffany!
We was literally
Talking
talking about
about
your
you.
cat, Tiffany.
What's your cat's name? Okay, well, I'll start. I got one cat. Ugh.
Betty. Betty's the name.
Betty. Hi, Betty.
Oh my God, there's two cats. Holy shit. I saw you grab one cat and I like looked down to check my microphone. I look up and you have two cats.
This is Freba. This is Steve. Steven's real name is T.T. Eumenidius the Third. That's what the pet shelter named him. It's like some constellation or planet or something. He's now just Steve. The kids call him Tina. Yeah, we got too many cats. Oh, Dover, a nice cat. What is your cat's name?
That one was Storm. I'm trying to get Midna over here.
Did you say Midno?
Midna.
Midna. Like is
You.
this like a Zelda reference?
Yeah.
Oh, nice.
Where'd you go? Here you are. Come here. Everyone wants to see your face.
It seems happy about being on camera.
Want this?
Mike, do you have any pets?
I do not. I do enjoy spoiling others.
This like a gift giving of pets?
No, giving them too many treats when I'm interested to watch them for a little bit, stuff like that.
Oh, nice, nice. Yeah, that's been a real problem with the two cats that I have is like food portion control. Like both of my cats, every time I take them to the vet, they're like, "Oh yeah, they're overweight. Yeah, you need to like cut down on how much food you're giving them." And I don't know how you do that with cats. Like it doesn't make any sense to me, but anyways, long time no see. Good to see everybody. I know last time that we talked, I was like, "Hey, I'm not going to see you until we're at the finish line," but I lied. Here I am. Max asked me to come in and um, talk about something. I was originally going to talk about TypeScript, and I know that potentially he already mentioned that I'd be talking about TypeScript. I'm not talking about TypeScript. I'm going to be talking about testing tonight because I don't feel like I'm qualified to talk about TypeScript. I'm not a very good TypeScript developer. Honestly, I'm not a very good JavaScript developer. But I do have some stuff that I want to share with you tonight. Tonight will kind of be a short class. I don't think it's going to take very long to get through some of the stuff that I want to talk about. Before we jump in, though, I have a question. How many folks, since the last time I saw you, how many folks have pushed to GitHub? I got
Me
a
all the
couple-
time.
Yeah, yeah. I mean, I've been using it for my capstone too. So
Daily,
Oh,
probably.
Capstone and the New York Times API project, but besides that, no.
well, that's fantastic. Sometimes I come back and folks haven't touched it at all. So I'm going to give you the opportunity to prove your prowess with GitHub. And if you don't remember, we'll go over how to use it again. But this is just a quick exercise, and I'm going to use it for attendance. So the goal for tonight, real quick, the goal for the next 15-ish minutes is going to be to push a commit to a repo. I'm going to create it live. So let me go ahead and share my screen. Okay. Is everybody able to see? I've got github.com pulled up here. Is everybody able to see my screen okay?
yeah.
Quick refresher, you don't need to do this. I'm going to do it on my end. I'm going to create the repo and then have everybody push commits to it. But just as a quick reminder for the folks that maybe haven't seen this in a little bit, creating a new GitHub repository is as simple as going to github.com, clicking on the little plus icon. I'm going to create a repo called attendance part 2. Because if you recall, when we were doing our class, there was a repo called attendance. I'm going to create a different one called attendance part 2 and add a README to it, because if I don't, it gives me a bunch of really confusing things that I have to enter in. So I'm going to do this. Don't create a repo on your end. I'm going to create the repository that everyone's going to is going to merge to. All right. Now, if I recall, the way that I get all of you access to this repository is I go into settings and then I go down to contributor and I send you all email invites and then you accept the email invites. That's going to kind of be a hassle. Better idea. Let's just use the old one, because everybody should still have permissions, collaborator permissions on this from last time. If you don't, let me know. But let's just have everybody commit something to this attendance repo, and I'll walk through it on my end if you don't remember how to push a commit. So I'm going to open up GitHub Desktop and switch to the attendance repo.
Did we have access to that already? The only one I have is animals. That's forked from yours.
Oh, Joe, is that you
Yes.
saying that? Okay. Let's go and look at contributors really quick. Collaborators. Yeah, Joe, invite expired, it says. Let's resubmit that invitation.
Well, that would make sense.
Check your email. You should have an invitation to this repo. Anybody else? Looks like everybody else was able to accept their invite.
Yeah, can you reach
Just me.
Because I don't.
Mo, it looks like you're already in here.
Uh-oh. Okay.
So Just as a reminder, in order to work with this repo, we need to open up GitHub Desktop. If you click on this repo picker up in the top left and you don't see attendance, you can, so for example, I'm going to just nuke mine. If you don't see attendance there, just go to add, clone repository, and then on the URL, you can type in Lux attendance, and I'll also paste this into the Slack chat. That is the name of the repository you're trying to make changes to. Once you are selected on the attendance repository, just open up VS Code somewhere and make an edit to it. If you already had a file in here, like I know a couple of people created their own files, like for example, I did. Feel free to just make a change to it. And if you get this error where it's saying there's newer commits on remote, just fetch until you can push it. All right, I'll give everybody a second to make a commit to that repository.
I think that worked. I'm not too sure.
Let's see.
You just wanted us to make any kind of edit, right?
Any kind of edit. And what'll happen is on the repository, because people are making edits to it, I could just click on the commits. Remember, commits are just snapshots of each of the individual changes. I can just click on commits and I can see all the commits people have pushed. So here's what Tiffany, Terry, Joe, Tiffany, Christelle, Mo.
I may
I
need some
can see.
help.
Yeah, that's what this is all about. Do you want to share your screen? Oh, should probably. There we go. You've got the attendance repository. Cool. Did you make an edit on your local machine?
I guess I don't really know what that means. I'm one of the people who has not touched it since we last talked.
No worries. That's what this is about. So open up attendance and VS Code. So open in Visual Studio, punch that button there right here.
Thank you.
And then pretty much anywhere in here, just make some sort of edit. Yeah, kick them out. Nice. And then yeah, save and then go back to GitHub Desktop, and it should show that you made a change. Perfect. Commit and push. The commit button is yep, exactly, and then push. And because there's all of us trying to push simultaneously, yep, go ahead and click fetch. This is just going to catch you up on all the edits that have occurred. Pull origin, keep clicking that blue button. Push. Yep. And so you got lucky on that time that in the time that you pulled and then pushed, nobody else had pushed. You may have to repeat that for anybody else. You may have to repeat that if you get unlucky and someone else pushed at the same time. But
Mine's
yeah, perfect.
bouncing back. Oh, there it go. It worked finally.
Yeah. I mean, this is kind of the downside to a bunch of us trying to push updates to the same repo at the same time. Nice job, Mike. All right. Somebody else was saying they might be having problems. Ozma, let me check. Ozma, looks great. Just give a couple more minutes for folks to push to that. Uh, Jada looks good.
Oh, you still waiting
A,
for me?
a beer. Hazad, yours is you're able to push. It looks good. A beer. When you say how do you select the attendance repo? Do you want to share your screen or do you want me to show you on my end? Cool. So you have the animals selected. Go up into the top left where it says current repository. Yeah, switch that. Click add. Yep, clone repository. So go and grab yourself a copy of the attendance repo. So it's DE1UX, DE1UX. Yeah, it's also in the Slack chat, whatever you want to grab. DE1UX/attendance. There, I can type it out really quick. That's right here. Yep, that's it. So go back to GitHub desktop. Click on add. Yep. Well, yep. Paste. Perfect. Open up a VS Code. Make some sort of change to the code there. That is something else. So click that open in VS Code button. Should launch a new window for you. There you go. Yeah, you trust it. You can make an edit to anything. It doesn't matter. Any file, whatever you want to do, just edit something. Cool. Make sure you save. Okay. Nice. Push. Perfect. Nice job. Okay. All right. Anybody else? Otherwise, we'll go ahead and get started. Water. Okay. All right, I'm gonna paste a link to the slides if you don't want to stare at my screen. And I don't know if these slides are shared. Let me quickly change this. Oh yeah, it's view. It's visible. Okay. All right. So a little bit of a story to this. Back in cohort 2, I didn't just teach DevOps. I also taught 2 other classes. I taught a class on cryptography, and then I also taught a week of testing. And tonight I'm going to try to distill a week's worth of testing into roughly an hour. And I cut out quite a bit, and I hope that this still makes sense. This is kind of the same thing as when we last met and I talked about Git. When you after you graduate and enter into your career as software developers, just like Git, another software engineering practice that you're going to encounter is software testing. And while knowing how to code and build things is really useful, just like being able to know how to use GitHub and knowing how to deploy things, there's more than just writing code. There's more than just learning about JavaScript. There's a lot of extra software engineering practices that come with it. So that is kind of the motivation for talking about testing tonight. So a little bit of backstory. I'm going to walk through an example here in a minute, but a little bit of backstory. This example comes from when I got my start as a software developer. The very first job that I ever got paid to write code for was this right here, this building, actually. I worked at a textbook store, and at that textbook store, I wrote a website that effectively let you buy back books. So this business would buy textbooks, and on the website you could enter in, a textbook's ISBN, and then the software would look it up on a pricing guide, and then it would offer a certain amount of money for that textbook. One of the functions, so I am a junior software developer at this point. This is like roughly 2009. I am a junior software developer at this point. I barely know enough JavaScript to be able to code together a website. And one of the things that I wrote, one of the functions that I wrote was something that looked a lot like this. So that textbook store I worked for, we would offer kind of a flat amount for certain textbooks. Like I think it was like 50-ish%, 60-ish% of the value of the book, because of course the textbook store wanted to make some profit. So they didn't obviously give you 100% of the value of your textbook. But there were some exceptions to that rule. And one of them was this idea of partner schools. So the textbook store would give a certain amount of a discount, or rather would give more for certain books if the student that was going to trade in that book, if that student belonged to one of these partner schools. And so one of the functions that I wrote on my website is if they were logged in and they belonged to one of these universities, we would change the pricing algorithm, and we would change the amount that we gave them. Pretty straightforward. Any questions so far? Yeah, so anyways, this is kind of the function that I wrote, and I launched it, and I had the website live for a couple of days, and then all of a sudden I got this email from my boss saying something is wrong with the website. Everybody is getting a discount. It doesn't matter if they were part of the partner schools. We were giving that discount to everybody across the board. And I don't know if anybody was able to catch it in this snippet of code right here, but the offending line is right there. So does anybody know what index of does?
Grabs the
JavaScript
index
function?
from the of the current place in the array as it's mapping over it.
Yeah, yeah. So so for each of these partners, so for each of these strings, we're looking to see if this shopper matches any part of that string. So it's basically searching for the shopper, or sorry, searching for this string within that shopper, within that email. Does anybody know what index of returns if it finds a match?
Is it
Well,
a Boolean?
let me be the first to show you how index of works. This is a JavaScript function. So if we go and type in ASDF JKL, and so does everybody agree that that is a string? Okay. So if we do index of, and then we look for I don't know, hint, it returns -1. So the index of function, if it is not able to find the thing in the parameters, the thing in the argument, it always returns -1. However, if it's able to find the thing that you specify, so let's say ASD, it returns the position at which that thing starts in the string. So if I do JKL, we would get, let's see, 1, 2, 3, 4. 4. So this is a way to test and see, does a string contain another string? Does that make sense? So it's similar to like kind of like a needle in a haystack, where if you're say our haystack, if I do, oops, let a, let's not use the variable a. Let's call this b. Just kidding. I don't know what's going on here. Let's do this. So does everybody agree that the variable b holds the string haystack? If we do b dot index of stack, well, I just gave away the answer. I was going to say, what do people think that this would be? It would be 3, because stack starts at position 3. So 0, 1, 2, 3. Does that make sense? So why is this code bad?
I
Let's
put
wa-
something in the comments. My preliminary guess is people tried to get around that by putting like making like what I put in the comments, nyc.edu at like any other email domain.
That's a really good observation. Yeah. That would be one way that you could spoof this. But it doesn't, so if I go back for a second to this hypothetical but very real, this happened, by the way. Everybody got the discount. Everyone. So, and it goes back to the mechanics of how index of works. So let's walk through this code for a second. So we have an array of strings, right? These are the things that we want to match on. And if they have any part of that in their email, in this shopper email, we want to give them, we want this Boolean match to be true. So for each of these, we go through this shopper.index of partner. This returns a this ends up returning false, because index of is sorry, sorry, 1 second. I think that this is actually never going to offer a discount, because if Oh, let's see for a second. Is -1 truthy in JavaScript? I think it is. Or for example, if we were to do -1 equals true, no, it's not. Whoops. -1 is not false. That is not true. Let's see. If -1 console.log. Oh yeah, okay. So this is truthy in JavaScript. Yeah, so that is the source of the bug here. My bad. I apologize for needing to look that up for a second. So this evaluates to -1 if it doesn't find a match. So in this example, each of the shoppers did not have this in their email address. And so when index of does not find that string partner within the shopper, it returns -1, which in JavaScript evaluates to true. So in this example that I needed to test really quickly here, if we just evaluate if -1, it returns console.log, which effectively gave everyone this match. Go ahead, Joe.
So just to make sure I'm understanding index of properly, I mean, you'd
Mhm.
want to use that in the context of checking where something is in an array if you know for a fact that something's going to be in an array. And then if it's not, that's when it would return -1 because that wouldn't be a valid index anyway.
Well, you can use index of to check whether something exists or not. You don't need to you don't need to check beforehand using something else. You can use index of for both. You can use it as a way of detecting, does this haystack contain the needle? And you can also use it as a way of finding the position of something. It'll do both.
Right.
Um,
I guess I misspoke a little there. You wouldn't need to worry about the logic um error there because you would never have an array index of -1. So if you got something that returned -1, you would know that it's not in there. That would be
yeah,
like a
exactly.
surprise.
Exactly. And that's the bug that's here, is that when index of doesn't find a match. So if partner is not in shopper at all, index of returns -1. The issue is in JavaScript. So everyone's familiar at this point in the class with the concept of booleans, of true and false, if else statements. The problem is JavaScript, if this evaluates to -1, which is what index of returns if it doesn't find a match, according to JavaScript, -1 is still a truthy value. And even worse, if index of does find a match, and I know this isn't a valid email, but let's say that the shopper's email was nyu.edu, that would return 0 because that would be the very first part of the string, which would give them a match. So I guess technically that would work. Anyways, very long story short, because I need to refresh myself on the mechanics of index of. Long story short, the fix for this bug is really to test explicitly for -1. If you are able to find, if index of returns anything besides -1, so greater than -1, it can be 0, it can be 100. If index of is able to find a match, then we give them the discount. I apologize. I needed to look up the semantics of index up for a second. Does anybody have any questions about how that works? I don't remember how much money they lost, and it didn't end up coming out of my paycheck, thankfully. I think because we technically hadn't entered into a contract to buy these books back, we just ended up canceling the orders. But it wasn't a good look, and could have been easily prevented with what I'm about to show you. So is everyone familiar with console.log? Have you used console.log ad nauseum during this class? So I'm going to show you something else that console will do. So console is a package in JavaScript and has a bunch of useful utilities. But one of the utilities that it has is a way to do what are called assertions. And assertions are really just a way of you proving that something is true or false. But in most contexts, we'll just be talking about proving that something is true. So I'm going to give you an example really quick of how console assert works. Everybody's able to see my terminal. So you could do console.assert. What is something that we want to assert? What's something, is anybody, tell me something that's always true in JavaScript.
1
No
equals
matter.
1.
1 equals 1, okay. How about we assert that 1 is equal to 2? So this is the power of console.assert. If you tell it something that's false, it will throw a big error. How is this useful? Well, you can write proofs. You can essentially write proofs that prove that your code does what you think it should do. So for example, using the assert statement, we can call this function should offer discount. We can call it with different kinds of inputs and assert that it returns a specific thing. So for example, if we pass in nathan@gmail.com, which isn't one of the partners, should offer discount, should return false. The match should be false. If our logic is correct, it should be false. So we can write out these assertion statements that will prove that these things are either true, or if they're not, we'll get one of these. Big. Pull that back up. We'll get one of these big red errors in our console logs if it's not. And if it's not true and it throws this assertion, we can go and find out, okay, what broke? Did we change some code and accidentally break something? Or was our code never right to begin with? And in the second example, here are some console asserts that prove that if we have emails that belong to one of our partners, the function should return true. So these assertion statements allow you to codify the behavior of the functions that you write. They also let you do something as software development, and we'll dig into this into a real example here. So if you're like, okay, that's cool, but I don't really get it, stick with me. We're gonna work through an example here in a second. But this also unlocks another really cool software development practice called test-driven development. And the idea is that if the boss says, okay, I forgive you for costing the company thousands of dollars, can you also make the code in addition to partners? Can you also make the pricing code give the owner's nephew a discount as well? What this pattern unlocks is it lets you write things like these assertions first, and then come back and write the code. And what that allows you to do is it allows you to write these proofs. It allows you to write these assertions that at first will break because this code perhaps isn't written yet. And then you can go and write that code. So it changes. I know right now for the capstone, for the homework, for all the exercises that you're doing in class, you just go straight to writing the code, right? Like you learn a concept and then you just go in and you go and start hacking on it until it works. I'm going to show you a little bit of the inverse, where instead of just jumping straight into the code, instead we write a little bit of code, but not directly solving the problem. We write a little bit of code that talks about the behavior of what we expect the code to do before we write the code. It's a lot of words, and I'm not expecting it to make a whole lot of sense until we dive into an example, which we'll do here in a second. Before we do that, one really cool thing to talk about is the Therac 25. Has anybody ever heard of this? If not, this is a pretty cool example of where testing is pretty important. So this was back in the mid 1980s. Software programmers that programmed the Therac 25. This was a radiation machine, so it was supposed to basically rotate into different orientations, targeting different parts of the body, and give a precise and controlled amount of radiation, presumably like chemotherapy style radiation. Anyways, software engineers totally messed this up, and about 6 accidents. This is kind of a classic case for software testing. This is why if we write software that is critical, like things that deal with pricing, things that deal with authentication, things that deal with money and lives, this is why it's really important to have tests to be able to prove that your code does what you say it should. I mean, I don't think people outright died from this, but pretty substantial doses of radiation from a software bug. I believe that the root of the software bug too was a type mismatch. Other causes of software defects: friendly fire during the Gulf War. 28 soldiers killed because of a GPS guidance issue, which was related to software testing or the lack thereof. And then there's a couple papers that show that the amount of untested code in the US costs on the order of billions. So there is a economic impact to not testing your software. Will you have to do this for your capstone? Probably not. Will you have to do this professionally? Absolutely. Where I work at Datadog, if we make code contributions to the code base without tests that prove that the code does what it's supposed to do, we have to justify it. It's the exception and not the rule. All right. So I'm going to actually skip over all of this because we don't really have a lot of time. But I do want to quickly talk about strategy when we're developing these tests. You really want, when you're starting to write tests for your software, you want to break it into 2 categories. And you could kind of think of this as what should the code be doing and what shouldn't it do, and then writing test cases around that. So for the Therac 25, for example, if you were to be the one writing tests for it, you would probably want to write some tests around ensuring that the code that sets the timer for how long the radiation dose is being given is accurate. And then what it shouldn't do, well, it shouldn't give an unsafe amount of radiation for an extended period of time. So when you're testing a function, it's the easiest way to think about it is breaking it up into those camps. What should it do and what shouldn't it do? So if we go back to the example of what the pricing algorithm should do, there's really a couple things that are happening here. We have this block here that is going to ensure that the boss's nephew, if that's the email that's in here, is going to return true and get the discount. Otherwise, and the partners as well. Otherwise, it should return false and not give anyone else a discount. So when we write our tests, those are the test cases that we want to cover, or those different situations. Any questions about that so far?
Yeah, I guess you're probably not going to go into this tonight, but how would you approach something that's not necessarily going to lead to a very obvious error? Things like designing algorithms based off of automated approval for different banking systems for like loan approval, or like Compass, which is the probationary algorithm.
So is the question, how would you test something that's really complicated?
Yeah.
I have answers for that, and we probably will be able to get into that tonight. I'm hoping that we can get into that tonight. That is going to be one of the last things that I talk about.
All right.
The answer to that is there is nothing that can't be tested. It's just how much time do you have, and sometimes how much money do you have too, depending on if it's a computationally expensive thing to test. Okay, so we're gonna skip past all this. Yeah, okay. Let's just dive straight into some code. So what I would like everybody to do is I have a repo that we're going to work out of. There's 3 examples that we're going to look at tonight. I'm going to show you 3 different ways of testing things, starting with console assert, which we've already done a little bit of. And then we're going to look at using a library called Jest. And finally, we're going to use another library called Cypress. So I'm going to show you 3 different tools that you can use to test your code with. The last one, in my opinion, is the one that I see students using the most, but I still want to give you the option of using the first 2. Okay, so how do you get this code? Well, the answer is you can just open the link that I sent you. Alternatively, what I'd really like folks to do is I would love for you to clone down this repo. So we went through the exercise of cloning the attendance repo. A couple people needed to clone it if you didn't already have it. I want everybody to go into GitHub Desktop though, and to get this using GitHub Desktop if possible. So opening up GitHub Desktop, going to add, clone, and then pasting that in. So go and grab yourself this code so you can follow along with me. Is everybody pretty familiar with create React scripts at this point? Used it in class? You've created a couple React projects? You know your way around a React project? Well, this will be your opportunity to get more familiar with it. I'm not hearing anybody. I don't know if folks are kind of like, yeah, I kind of get
The
what it looks
silence
like.
was the answer.
Okay.
Yeah, literally.
Okay. Well, here's some more practice tonight. That's what I'm here for. All right, grab yourself that, grab a copy of that repo and then pop it open in VS Code. We're going to take a look at what's in here. So I've got 3 create React. I literally went into each of these folders. I did np like Joe just pasted into Slack. I did npx create React app, and I created 3 separate React apps to demonstrate what we're going to talk about tonight. But this is a GitHub repo. We never commit our node modules, which means that we need to go into each of these. And if you want to run them like we're going to do tonight, you need to go into each one of these and do npm install. So I'm going to go in. The first one we're going to look at is console assert. So if you open up the console assert, you can right click on it, open an integrated terminal. Just go ahead and do an npm install inside of that folder. So that will download all the node modules. That will get that project ready to go. Grab a little bit of water. If you do npm install, all of a sudden you should see a node modules folder in there. Bunch of libraries and packages downloaded. Do an npm install inside that console assert folder. And then the other thing I want you to do, just like with any other create React app, I want you to do an npm start. pause here for a minute to let people get to this step.
I am
If you
getting an
haven't,
error.
what area are you getting?
Let's see here. eJSON parse brings the file path to package.json. Unexpected end of JSON input while parsing empty string. Failed to parse JSON data.
All right, show me what you got. Let's see.
It could very well be related to yesterday when I broke React.
So you are sitting inside of testing crash course, console assert, npm run start. Have you
Oh,
done
should I be
an
in
npm?
source?
No, you should be right here at the top of the root. What's in package.json?
Nothing.
It's
It
empty.
looks like
Why is your package JSON empty?
it could very well be just a me thing because I did break React last night.
So go into GitHub desktop because you just cloned this down, right? Can't find testing crash course. Did you move this around?
Nope. It brought this up earlier when let me see if I can get this back in here. Just gonna open that and no. Interesting.
I'm actually having a different error. Like, I can't like connect to the site like at all.
Okay, so do clone, hang on. Slow down for a sec. Do clone again. And when it says, would you like to retry, hit cancel. Okay, actually, go back up to the top left, select repository, clone, hit, no, ignore this. Go back to the top left. Go
Oh,
to
you mean
add, yep, clone. Same thing. So DE1UX / testing crash course. Yep. And then when it says choose, yeah, change that to 2. Like put a 2 at the end of the course. We'll put it in a separate folder. Yep, 2. Perfect. Clone. All right. Then open that one in VS Code. Make sure you don't get confused with the window behind you. The window behind you can get rid of. Same thing now. Go to console assert, do an npm install, and then an npm start. Also, your package.json should have stuff in it now. Yeah, nice. Yeah, npm I, the shortcut. Very nice. npm start. Whoa, what
Yeah,
happened?
that's literally the same one I have and everybody else.
Show me what's going on in the terminal. Go back to the terminal. Unsupported and what? Digital envelopes unsupported. OSSL. And other people are getting this as well.
Yes,
Mike.
I
Yep.
am.
Okay,
Yes.
interesting.
Yeah, I got the same thing.
it's not just me, yay.
Okay, well, I can probably fix this. Give me a second. Let's do. Actually, let's do this because I think it's going to take me more than a minute to fix this error for everybody. Let's go ahead and have our first. Let's go ahead and have our break now, and then when we get back, I'll have this fixed, and everybody could just pull. And we'll dive into the example after that. We can fix this. Back at what is it? It's 6. It's 6:30. Let's be back at 6:50. Sorry, 6:40. Back at 6:40.
Should be 25 minutes, right?
Back at 6:45. Thank you. Oh, my math is bad. 6:55. Thank you. I think I fixed the issue while we were on break. So to confirm that I did, I need folks to open up your GitHub desktop, and then up here in the top right where it says fetch origin, I pushed some code. So go ahead and grab it. Just click on fetch origin, and then it will say poll origin in blue in the center. So go ahead and do that. Grab that code that I just pushed that should fix issues we were seeing. Pull that code, and then in VS Code, let's open up VS Code. Go to console assert, open up that terminal, do npm install, npm start. If you're still seeing that error on npm start, please let me know. Oh, cool. DeAndre, you were able to get it to run? You were able to launch it? Excellent. Cool. It looked like the version of Create React app that I used to create these was a little bit behind. Michael, Sujata, are you all able to get the example to npm start successfully?
I do have a question because I started
Yeah.
over. I just pulled my I forked it again. Did we
Yeah.
pick to contribute to the parent project or for my own?
Yeah, feel free. Probably pick the for my own personal use.
For my own purposes. Okay. All right. That's all I needed. I was following along, but I got stuck there and I'm just like, yeah.
Okay. Well, once you got it cloned down, the only thing I want to remind is open up VS Code, click that open in Visual Studio, click on the console assert folder. There's three folders we're going to look at tonight. Click on the console assert one, open in integrated terminal. And then the two commands that I want you to run once you have a terminal open. The two commands I want you to run is npm I, and then once that finishes, I want you to run npm start. Just like any other Create React app. Anybody else? Oh, I can't run this because I have another terminal. So we'll get rid of that one. Okay. All right, I'm going to go ahead and talk about console assert. So it is just a regular Create React app. Once you launch it, it's got a username and a password. This is meant to emulate a login or a website. So users come in, they enter their username and their password. So the layout of the folder, it looks pretty much the same. The thing I want to draw your attention to though is this validation.js. That's where we're going to be looking at. So go ahead and pop open validation.js inside of console assert. This is where we're gonna be. While you're opening up validation.js, I just want to show how this function validate password is getting used. Back up in app.js, everybody's probably pretty familiar with this in Create React App. This is the primary component that, or the component that Create React App gives you. You don't have, there's nothing special about the app component, but this is the default one, and I just went with it. So, can anybody tell me what line 6 is doing? on my screen.
Is creating a use state.
Have you guys looked at React State?
We did. It's a new concept still for me, but you know.
So can anybody explain to me what password does? Oh, Joe, in GitHub Desktop, pull down up in the top right, hit fetch, and then pull origin. So grab the latest stuff because I pushed some code while you were away. And then once you do that, go back into console assert, run npm I again and npm start, and you should have the fix. Let me know if that doesn't work for you. DeAndre, you were talking about useState. So useState returns two things. It returns this thing and that thing. Can anybody tell me what these two things are? We know what the useState function does. It returns some piece of state, but specifically, what do these two things do on the left side after you've
Is it like
finished?
a variable that you're gonna like keep using or some sort of function you're gonna keep using throughout the code? So you want to reference it?
It's both of those things. So password is a variable and set password is a function. Yep, it's both of those things.
I know that password can't be changed, but we could use set password if we need to make changes to the password.
Exactly. 100%. That's right. You're given two things. Whenever you use state, it's like initializing a variable, but in React, it's more involved than just JavaScript, where you initialize a variable. Like in JavaScript, you get away with creating state by doing things like let a equal foo. That's creating state. But in React, it's more involved. This use state up here returns two things. It returns a variable that holds on to the contents of that state. And then it returns a function that you can use to change the contents of that variable password. So you get two things every time. It's a pair, it's a bundle. They're both tied together. So let's walk through and just try to figure out what's going on here. So there's some sort of function called onSubmit. Let's kind of ignore that for a minute. And let's jump down to the HTMX to the, what is this called?
Is it JSX?
There we go. Thank you. Yes, it's the special JavaScript React HTML hybrid thing. So we're rendering a div. Inside of it says enter your username and password. Has a little form inside of it. There's two input boxes. There's a place for you to put your username, and then there's a place to put your password. And then notice that I've bound to the onChange handler. I've bound this function set password. So anytime that the password is entered here, that password is going to get passed into this function, set password. And then whenever the user submits by hitting the submit button, it triggers this function on submit. So anytime they change the password in this box, we're going to call that set password function, and we're going to mutate, we're going to change the contents of that password variable. And then once I hit the submit button, this on submit function triggers. Now, this is where you come in. The validate password function is what we're going to look at. And validate password takes what the user has entered for their password and it validates it. Says whether or not this is a valid password that the user can use. Not whether or not it's the right password for the user, but rather if it's valid. So let's look at that. So with your validation.js pulled up, let's take a look at this function, validate password. So validate password, I want you to help me make validate password do three things. And if you've worked at a company where they expect you to log in and use their system, these will be very, very familiar to you. When we validate the password, we want to make sure that it adheres to these three things. It's greater than 7 characters in length. So they've chosen a password that's greater than 7 characters. It's not a commonly used password, so no picking password as the password, or 1, 2, 3, 4, 5, 6, 7 as the password, or sorry, 1, 2, 3, 4, 5, 6, 7, 8 as a password. And then we want to make sure that it has at least one special character. What do y'all think? You think we can, do you think we know enough JavaScript to be able to do this? Tiffany, I saw you shake your head. Anybody else feeling up to the task? A couple more head nods. Okay, cool. Well, let's do it. Before we jump into the code, though, I want to introduce the concept of testing. Remember console.assert? Let's use that really quick. And before we write a single line of code to validate password, let's assert what the behavior should be. So console assert, remember that console assert is going to fail and throw a big red error in the console if what is passed into the arguments, what goes here in between these parentheses, if you pass it anything that's false, it's going to throw a big exception. We don't want that. So what we want to do is we want to assert what validate password should do after we implement these three things. So can somebody tell me if we validate password and we do, let's see, A1, B2, C3, D4, E5, exclamation point. Would that be truthy? Would this console assert pass? Should it pass? Does anybody know?
Yeah, because it has a special character.
And it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 11 characters in length. It has a special password. I don't think it's a commonly used password, but it also isn't very secure either. But should this pass our test? Would validate password return true and console assert whenever you pass it something true, it won't throw a big red X. Is this assertion true? Is this a valid password?
I would say so if it's not a commonly used password.
Cool. I agree. I think this is a good test case. This is after we write this code to do these three things, this should be a valid assertion. That should be true. All right, let's write another one. If we do console.assert validate password A, would this assertion pass? Again, we got to use our imagination. I know right now that this function says return true. And so right now, if we ran this code, it would technically be, this function would technically return true. But pretend that we've already written this code. Is this assertion true?
No.
No, because it's shorter than 7 characters. So this should be false. So our assertion is not that validate password A is equal to true. What we want to assert is that is equal to false, right? We want to lock in that behavior. We want to make sure that validate password, however we code it here in the future, if we put something in that's short, it's going to return false. And sorry, this is JavaScript, triple equals. Also, I'm going to expand up here and I'm going to make this equal to true. I just want to really make it clear that we're writing test cases here. We're comparing the output of this function to true or false. Also, I want to point out that console assert actually does take a second argument. You can specify a little message about what the assertion means. This is just a human readable thing. It's kind of like a git commit. It's meant for you as the programmer. So right here, what I'm going to do is I'm going to say this is a valid password. I'll show you what this does here in a second. This is too short. Okay. Let's do a couple more. So let's write one more console assert. Let's do validate password. So earlier before the break, I was talking about when you're writing these kinds of tests, you want to break your code up into things that it should do and things that it shouldn't. And that will help you to think up of the test cases that you could potentially write. So can someone give me an example of some input to validate password and what the expected output would be?
Just anything.
All right. And what is the expected output?
False.
That would be false. Why?
Well, there's no special character. It is a word in there, so I would assume that a word would be commonly used. 1, 2, 3, 4, 5, 6, 7. So it passes the 7 characters.
Oh, good catch. Yeah. Okay. So I think that is the only case that we're talking about. If we, I don't know how in depth we want to get with commonly used, but
Right. Definitely fails.
But yeah, that is a great test case. And if you're keeping track in your head, we've covered the good case where we pass it a non-commonly used password with a special character with seven characters. We've written a test for that. We've covered it being too short. We've covered no special characters. Anybody think of one more assertion that we can write to cover all of the possible branches here?
All right,
Use a
ready?
commonly password.
There you go. Exactly. Common password would be
Password.
password. Wait, what is it actually though? Most commonly used password.
Probably 1, 2, 3, 4.
Yeah,
Yeah.
there we go. 1, 2, 3, 4, 5, 6. We did it. And what would this assertion, if we write our code correctly, what do we want this to equal?
False. It would fail test case 1 and 2 and 3.
2 common. Yeah, exactly. And so it's not specifically, yeah, that's a good point. So it's going to probably fail on the first one before it gets to the second one. So maybe let's do that. It'll pass the first check, but it's definitely common. So
Well,
let's
you should have it go up to 8, right? Because it's greater than 7.
oh, good catch. The requirements do not have an equal in there. Good catch. Yep, 8. And that's too common. Cool. So we've written assertions. We've basically written a proof that shows that once we write our code up here in this block, all of these things should pass and there shouldn't be any red in our terminal. Now watch what happens if I go into our app right now, and I'm going to open this up. Notice that I've got a bunch of red errors in here. And that's because these assertions are failing. The things that we're trying to assert here, that this is true, this is false, this is false, this is false, all of those assertions are failing. Why? Because our code doesn't do anything. This is called test-driven development. You write what your code is going to do, you lock in that behavior, and then you go and write the actual code. So now we can jump ahead to implementing these checks. And as we implement them, what we should be able to do is go back to here, refresh this page, and see those red errors start to bleed away as we fix this behavior. All right, let's do the fun part. Let's write some. Well, depending on how you look at tests, let's write these 3 things here. So first one, check that the password is greater than 7 in length. Somebody give me some code here.
If I don't know, password string dot length is equal to
Password string dot length.
Can I do dot length? Am I messing up Java there? Can't remember if this JavaScript or if because I'm doing both classes at the same time, so I'm like mixing stuff in between all the time. I think dot length is a proper.
How do we measure the length of a string?
Yes, you can do dot length. in JavaScript. It'll return the number
Okay.
of characters or elements in a string, array, or other object.
Perfect. Somebody else. What am I missing here in this conditional?
Greater? Some?
Okay, greater than 7. So if my password length is greater than 7, I'm going to return false. All right, let's go and see. One of these test cases for sure, we know that this one specifically deals with too short of passwords. So we should see one less error when we refresh our page. Okay, so we're still failing the this is too short test. So let's go back and look at our code. If password length is greater than 7, return false.
Shouldn't that
Yeah.
return true because that's what we want?
Good catch. Let's switch that. So we'll return true. All right, let's move on to the next. Tiffany, I see where you're going. Run with me for a second. Let's move on to the next one. So we've implemented check number 1. Let's look at check number 2. So what are some commonly used well, let's back up. How do we want to express these commonly used passwords? What kind of data structure can we use to hold on to?
You
An
could
array.
compare all the different
Hold on the
passwords.
comparison. How are we going to store the different types of commonly used passwords, right? Like we need to come up with a list of what we think are common
Definitely an
passwords.
array. Sure,
An
array.
array.
An
Oh,
array?
Yeah,
Okay.
push the e.target.value.
Well, we're not dealing with e.target. We're dealing with this is the password
you mean
that's
just
coming
like
in.
creating a static
Yeah,
array of
yeah.
commonly used passwords. I see what you're
Yeah,
saying.
yeah. How do we do that in JavaScript? How do we create
Uh,
an array of
uh, const common array equals an array of things that are common.
okay, give me some common stuff. Well, we said
Pass.
that this is for sure common, so we should probably throw that in there. What else?
We can go with password.
Okay.
Admin.
Admin 1, 2, 3. Okay. Come on, somebody's got to fess up here. What's your guilty common password? ABC 1, 2, 3. I like it.
Secret.
It's secret. We got to make it to 8 though, because right, secrets. There we go. All right, I think that's good enough. Okay, so we've got a list of common passwords. Now, how do we check to see if this is equal to any of these? How do we check to see if what the user gave us is equal to any of those?
You could do a for item of common array and iterate through, and if as it iterates through, check if password equals item.
Like this?
Do I have that right? Am I logically thinking that, or it should be the other way around? Or does it matter? No, it shouldn't matter because it's just checking to see if they're
If A equals B or B equals A.
Yeah.
So if one of these is equal, what should we do?
Return false.
Because it's not valid? All right. Everybody agree so far? Does look like reasonable code? Okay. Well, let's say it is. All right, let's move on to the third one. Make sure it has at least one special character. So we could write some super generic code, right? That is something like, what are all the special, I don't know why I'm doing, it needs to be camel case. I apologize for the inconsistencies here. Let's also not call
Oh,
this array. There we
There's
go.
there is an error with the logic in that loop. Because if the first one is not equal, it's only going to run that conditional if they're equal, right? So if the first one isn't equal, it's just gonna break and say that it's true, right? Or no, it'll iterate through all of them.
Only when they're equal do we bail out of the loop. Otherwise, we do nothing. There is no else clause here. So we will continue to fall through the loop. So only when these two things are equal do we do something in the loop, potentially returning false. Otherwise, we're going to keep going through each of the items. Good catch though. For special characters, we could do something really generic here. Like we could create an array of all possible special characters, right? But let's save ourselves some time here. Uh, let's just say we're only going to test for the dollars, or sorry, for the exclamation point. But let's use a list here. Let's pretend. All right, whatever. I'm going to put a couple in here. These are the special characters that they have to use. All right, how do we test to see if the user has one of these special characters in the password? Hint, I talked about this function earlier. It's the one that had the bug. What can we do? What function lets you search for a string within another string?
Index of,
Index of, that's right. Index of is a function. So let const index equals, let's see, password dot index of. Now, special characters is a list of strings, right? Of all these possible special characters. Index of, so if you want to call index of on a string to find out if it contains another string, we need to put that other string in this argument here. So like we could do that, right? Because this is a string. So index of takes a string and it looks for it in the box that you're calling index of on. If we pass special characters, it won't work. Because special characters is an array of strings. Index of doesn't work on arrays of strings. So we're missing something here. Joe, we could do that. We could definitely do a match on a regex. I'm trying to bring it full circle back to using index of, because it's a pretty common function. So how can we do this test to find the index to be able to search for one of these special characters from this array? How can we do this test on each of these items in the array? What do we need?
A loop?
A loop. That's right. When you see a list, when you see an array, immediately, we need a loop. We need a loop to deal with this. So what do we need to do? We need to do for special character. Oops. For let special character. So let's loop over each of these special characters. Okay, so I got my loop. What now? And let's move this inside. So I'm grabbing each of these special characters one by one. So let's do index of on the special character. Now we talked earlier about what index of does. It has a very special behavior. When it searches the string for that other string, it can return one of two things. It can return -1, meaning that it found no occurrence of that string that you're searching for, or it can return the index of where that string occurs that it found within the within the string. Yeah, exactly. So we need to have some kind of logic here that says if index is equal to -1, meaning that it didn't find a match, meaning we didn't find a special character inside of password. The index was -1, which means it's not there. If we don't find it, we want to return false. Is that what I'm understanding?
Oh, I was thinking like another way, like if like password of index of special character is not equal to -1, then return true. I was thinking of that, but
Okay, so if it's not equal to -1, which means that you found that special character, then you're saying you want to what?
return true.
Good catch. That was a great catch. We were about to find a bug there. Does anybody know what the bug is that we just avoided? Let's look at it for a second, and then we'll go back, Terry, we'll go back to your correct code.
Is it because we found out that -1 is truthy?
Possibly. Can you expand on that? What do you mean by that?
So like, would the console like even allow a false to pop up if -1 is truthy?
-1 is truthy, and console.assert would not throw an error if console.assert was given a truthy value. Let's walk through this though real quick. So what happens when this code runs? We've got three strings here, right? We're going to loop through here 3 times. The first time, we're going to do this check to see, does password contain the exclamation point character?
It would
Let's say
fail
for this
instantly if it wasn't that.
exactly. Let's say for this example that the password is password, and somehow we got to this block. I understand that up here we would have caught it, but let's say the password's password and we got down here. We would do this check right here. We would try to find the exclamation point by using the index of function. We wouldn't find it because $sign is not a part of the string password. We wouldn't find it. This would become -1. We would return false. That means we would instantly reject the password and we wouldn't continue looping over the other 2 characters, which is a bug. We want to check all the special characters before we fail a password, right? We want to look through them all. So Terry's fix is to only return true if you found something. And Terry, I'm going to switch your logic to something a little bit easier to read. I'm going to switch that to greater than or equal to 0. Slightly easier to read because when index is greater than or equal to 0, that means we have a match. We have a valid position that we were able to find that special character within the password. Yeah, it does the same thing. Your code and my code does exactly the same thing. It just reads slightly different. Okay, so are we happy with this? We've written code for all 3 cases here. If I go back to my web browser and I refresh, are we expecting all the test cases to pass? No red exceptions? Anybody want to put money on it?
Not at all confident, but I'll say sure.
All right, let's refresh. Oh no, we've got errors. We've got a bug in our code. All right, so let's go and look. This is too short is failing. So this case right here is failing. So we've got one of the 4 test cases passing. So let's take a look. This is the validate password. This is the case where we pass in the string A and we expect it to fail because this is too short. All right, let's take a look. So we pass in, let's just, for the sake of code here, let's replace that with that. Let's replace that with this. So if A length is greater than 7, return true, it's a valid password. What's the bug here? Tiffany already caught it earlier.
if the person's password isn't a parentheses, will it like not work?
Doing the test that we've written, password, this variable password holds the string A. It's one letter. So we're hitting this case and we're saying if 1 is greater than 7, return true.
We gotta make it less than, right? No, wait, no.
You're onto something here. What are we trying to catch here? We're trying to catch short passwords, right? Right now, this is saying if you give me a long enough password, it's valid. Return true.
What if
Don't
we,
Oh, and
even
it doesn't do
don't even
anything with
look
the
at it.
short passwords.
what
Don't
if,
even look at the rest of this stuff down here. Just if it's longer than 7, you're good. It's valid. That's what this says. What should this be?
We should always be checking to see if something fails instead of if it passes.
Um, I see where you're going with that. As a programmer, that's typically how we think. Like for example, here in this validate password function, I tend to think of here's all the ways that I can prove to you that it's not a valid password. So for example, the first thing I would do is I would check to see if it's too short. If it's too short, return false, fail. If it's too common, return false, fail. If you don't have a special character, return false, fail. Otherwise, you pass all that stuff, cool, return true. Um, so it's up to you how you want to write your code. That's part of the confusing part of booleans is you have to think of uh, things being truthy, things being falsy. So you can write code in really any way. I really like Dovere. I really like exactly what you wrote. If password length is less than wait, what was our original thing? If password is greater than 7 characters, so we're saying that it can't be 7, has to be at least 8 characters. So yeah, that works. Return false, right? Does that seem reasonable? I don't know about anybody else, but for me, this is way easier for me to understand, but that's just me. Okay, so let's see what happened to our test cases. Wow. Okay. So I refresh the page. We're down to one failing test. Nice job. Okay. So let's look at what this last failing test is. There's no special character. So what is the test case? When we pass in anything, we expect this to be false, right? So what's happening? Let's walk through this. We're definitely getting past this, right? Because our password length for anything is greater than 7. It's not one of our common passwords, so we're not returning false here. All right, now we get down to our special characters check. Remember that our password right now is really just anything, right? So somebody tell me what's going on here. When password is anything, what's happening here? When password is anything, do we even enter into this loop?
No, is it because it gets stopped for the common part? Oh wait, no,
Well,
that's
we
not
didn't
true.
say that anything is
That's
a
common.
common password. Yeah, so we're technically getting to this block of code here. Are we going to enter this loop? Are we going to loop through our special characters?
Yeah, right, because it doesn't have any special characters.
Are you saying, yeah, right? Like, yes, we will enter this loop, or no, we won't?
Yeah, I think we will enter the loop.
I agree, absolutely. Special characters is a list of 3 things. We're gonna loop through this 3 times. There's 3 things here to loop over. Exclamation point, @ sign, £sign. We're gonna loop through here 3 times. So the password is anything. We go through here, and each time we're testing to see, does one of these exist in here? If we do find a match, index of is gonna return greater than or equal to 0, and we'll exit. But this never happens, right? Because anything doesn't contain either of these 3 characters, right? So we loop through here 3 times. We never execute line 22 because this is never true. We never find that match. Cool. So we're done with the loop. Now what happens?
Oh, it passes it because it returned true instead of failing it.
Exactly. So down here, this is a culprit. Line 25.
We will need an else
What-
statement on that, right?
Say what?
An else statement?
An else statement on this?
Yeah.
So if we don't find the index, what do you want to do? If we don't find a match on one of these characters, what do you want to do? Do you want to return false?
Mm-hmm.
What'll happen if we return false here? Remember, we loop through here 3 times. Each time we're asking to see, is index, did we find a match? That's this line right here says, did we find special character? That's what this test is doing.
It's
we
going
find
to
a
fail
special
it every
character?
single time that the character doesn't match, even if it's a valid special character.
Exactly. Imagine our password was anything £sign. Because we loop through here in sequential order, checking exclamation point, @ symbol, £sign. We loop through here 3 times doing each of these checks. First we do that one. Do @ sign. Then we loop through here a 3rd time with the £sign. We'll never do these 2 cases, right? If our password contains the £sign, we'll never loop through and encounter these 2 because we'll fail on the first test and we'll return. We'll immediately execute and leave the function. So I'm going to get rid of that block. So what's the fix here? Well, I'll give it to you. The fix is return false, right? If we don't find a special character, if while we're looping through here, if we don't find one of these in the password and we aren't able to return true because we were able to find a special character, if we've exhausted looping through all these special characters, we didn't find anything after we got done with that loop, it's not a valid password, right? Doesn't contain that special character.
But wouldn't
right.
that fail the rest of them?
The rest of them, the rest of those cases should be handled here, right? They should contain a special character and we should be able to return out of this block.
But isn't the ultimate end of calling validate password returning false?
No, let's look at, think about how this validate password works. Think of it like a tree. There's lots of different branches that this code potentially could go down based on password. Let's look at all the different ways that code can execute and leave this function. There's this one, right? Your password could be too short. That's one way. You'll never execute the rest of this code. So that's one way of getting out of here. Here's the second one, right? If your password's too common, this is where that code will stop executing right here on line 17. It won't go any further. Here's door number 3. If you find a special character and you've made it this far, it's a valid password. And then finally, here's door number 4. If you have a long enough password, it's not common, but it's missing a special character, you're technically false.
I gotcha. I see. We're relying on just like the way the whole function's being run.
Right. Think of it, there's just several different paths that this code could possibly take. That's why testing this is so important, right? Because we've seen a couple of times here in this function where just by greater than symbol or return true being returned false, and there's lots of ways that you could get this code wrong. It's tricky. So these test cases help you to catch those things beforehand. And I think we've gotten them all. So if I refresh, this error is coming from create React scripts. But notice how we have no more assertion errors. All these tests pass. So we can feel confident that our validate password function probably does what we expect it to do. It probably does these three things. All right, what do people think? Is this cool? Is this lame? Does anybody think that this is helpful at all?
I think it's
I
helpful.
think it's helpful.
I think it's pretty
Very
dope.
much so.
Okay. I'll be honest with you. I've been developing software for a long time. I don't personally like writing tests. I like writing this stuff. This stuff is fun to me. This stuff though makes you a better developer. It's kind of like needing to eat your vegetables. Mo, I'm gonna beat you. There we go. If you do this for your functions, it will make you a better developer and it will help you to write better bug-free code. Okay, we're running out of time and I promised that this would be short. I'm gonna skip talking about jest because it's kind of like what we did here, except dressed a little bit better. I want to talk about Cypress because I think Cypress is really cool. Joe, you mentioned earlier, what would you do if the thing you were trying to test was really complicated? And the answer I have for you is robots. You would use lots and lots of robots to do it for you. And that's what we're going to do. I'm going to show you how to use robots to test your code. So as opposed to writing this kind of stuff, we can just get a browser to do it all for us. Also, I'm showing you the tools for doing scraping, if anybody knows what that is. All right, let's take a look at the Cypress folder. Same sort of deal. This is also a Create React app. So go ahead and open up the Cypress folder in a new terminal. Same sort of deal, do an npm install. This one's going to be a little bit slower because we're using a library called Cypress, and Cypress contains a robot that's capable of opening up a browser, and it actually downloads a browser when you do npm install. So might be a little bit slow when you do npm-i. All right. npm-i and npm start just Anybody having problems getting this Cypress spun up? Should look very similar to what we just had. Okay. All right. Also, we're running out of time, so I'm gonna probably do most of the hacking on this one and not pause as much on the first one, just because I want to show you show you this and also have some code in case you want to use it on your capstone to do some testing. All right. So before, what we were doing was writing some code and then executing it directly in the app, opening up the inspector and looking to see, okay, are those console asserts throwing any issues? Cypress works differently. So we have our app running here. We're going to spin up a robot to do some, some testing for us. So we need two terminals. We need to leave this one running that is standing up our app, but we need to open up another terminal for our robot. So inside of the Cypress folder, again, right click and hit open in integrated terminal. We need a second terminal. And the command to start up Cypress is /node modules Cypress, sorry, /node modules bin Cypress open. And I'll paste this command into chat. Also, this is on the slides in case you ever need it for future reference. It might take you a second if it needs to download the browser, but you should see a window that looks kind of like this. And what we're interested in is Cypress's end-to-end testing. So I'm going to click on that. And then it will let you pick which browser you want to use to do for the robot to use. I'm going to choose Electron. And then this project that we've opened has a file in it called app.sci.js. That's where our code that controls the robot lives. If you click on it, it loads up the robot, and we can see in this window, this right here is what the robot sees. So right now the robot isn't doing anything. It's just a blank page. So let's make the robot do some stuff. The way that you configure the robot is it has its own scripting language. Inside of the Cypress folder, there's another folder called Cypress, and then under the E2E folder, there's this app.sci.js. If you open that up, this is the folder that controls the robot. And so we need to instruct the robot and what to do. And I'm going to show you a couple of commands. All the stuff can be found on the Cypress website. You can look up Cypress tutorials and it'll show you all the syntax that you need in order to control the Cypress robot. But the first command that I'm going to show you is called visit. Oops. Visit. Visit takes one argument. It takes the path that you want Cypress to go and open up in the browser. So I'm going to have the robot open up localhost 3000, which is the app, right? That's our Create React app. So save that, go back to Cypress. Cool. When I go back to Cypress, it's already reloaded. The robot's already rerun. Check it out. So Cypress right here has loaded up. Sorry, my headset is running out of juice. Cool. Can everybody still hear me? Excellent. Okay. So check it out. The robot has pulled open the Create React web app, and you can see that over here on the right. Cool. Let's make it do some stuff. So sci.visit, think of sci is this special variable that controls the robot, and you use sci.something in order to get it to do things. So let's have it, instead of these console asserts that test the function directly, let's just have it go into the website and enter in some passwords, and we'll use that as our test to see whether or not those passwords are valid or not. So what we need to do is open up Cypress and have the robot click inside of the password box and type password and try to hit the login button. In this case, it says password is invalid because password is too short. No, it's too common. But how can we get the robot to prove that that's what happens when we enter in password? So this isn't showing up on my screen very well. Apologize. All right, so let's make the robot. Click in here and then hit the login button. The syntax for doing that with Cypress is first you need to find what it is that you want the robot to click on. There's this targeting button that you can click on up here, and it will help you find elements on the screen for the robot to click on. So we'll click on this targeting button, and then I'm going to click on that box. And this is a syntax that the robot needs in order to find that box. Sci.get password, because this element has the ID password. All right, so I'm going to go in here, sci.get password, and then you can make it type inside of that box. I'm going to have it type, let's have it do one of the valid passwords. So would you all agree that that is a valid password? Okay. Well, I'm going to hit save. When I go back to Cypress, notice how it has already entered in that password here. We can rerun the robot. This little button over here, this refresh icon, starts the test over again. We're going to rerun this as many times as we want, but our robot is now trained to load up the website, type in the password. Let's make it click the login button. So let's use our Finder to be able to find this box. So there's the box. I'm going to copy this text here. So once we've made it visit the page, type in the password. Let's make it click the login button. Cool. It says password is valid. All right, so now we have the robot typing in a password, hitting in login. We're missing one step here though, and that step is we want to assert that whenever we give it a valid password, the text password is valid shows up on the screen, right? We want to lock in this behavior with the robot that when it types in a valid password, we get this expected result on the screen. And so one way we could do that is password is valid. We can find password valid div and just do a .get. And let me show you what that does. So we have the robot visiting the page, typing in the password, clicking the login button, and then we have it trying to find the valid password div. That div only shows up when the user has entered in a valid password. So I'll hit save, go back to Cypress. Cool, green checkbox. Our robot was able to do all this and test for this valid password. All right, let's write one that fails. I'm going to create another one of these blocks. So right now we have a test where we check for a legitimate password, legitimate, somebody. I don't know how to spell. Is it I? Legitimate. Checks for a good password. Let's use that. Checks for a short password. Let's write out a case that proves that if they do legitimate. Just doesn't look right. I don't know. All right, let's write a test for a short password. So our robot's going to visit the website. It's going to type in the password A. It's going to click the login button, and then it's going to try to find valid password on the screen. Let's see what Cypress does. It failed. Why did it fail? It failed because it expected to find element valid password, but never found it. Why didn't it find a valid password? Why wasn't the robot able to find a valid password?
It didn't meet one of the conditions.
Right, it didn't meet our code that we wrote a minute ago. If you pass in a short password, we return false. And then our React app, if that function returns false, we display password is invalid. So our test case really should be looking for a div called invalid password. We're not expecting when we enter in a short password, we're expecting to find the invalid password. We're expecting to have that box displayed on the screen. Okay, so I'll fix this test case. Now our robot knows how to go in and check for both of these cases. They pass. Let's say that for some reason I'm like, I don't like the code that we used for our validator function that we were working on. Let's say that I don't like. Let's say that I don't think that this should be false. I want this to be true. I know that I'm introducing bugs here, but humor me for a second. And I'm going to change this one to true. And I'm going to change this one to true. And I'm going to change this one to false. Now, if I go back to Cypress.
You missed the semicolon.
Ooh. Oh.
Probably wouldn't have done anything anyway, but.
Now, if I go back to Cypress and I rerun. My tests are failing. Things are broken because I wrote bad code. I've got a bunch of red X's because my tests are no longer passing and my robot's not finding what it thinks that it should on our screen. Okay, so this is another way of accomplishing basically the same thing that we did a minute ago using console asserts, but this time we're doing it by having a user or having a robot interact directly with the website, pretending to be a user, going in and entering fields, and then this is our assertion right here. We're writing assertions. We're saying that if our code does what it should when we interact with our website, it should create these. It should create these divs. It should create put this text on the website. Does that make sense? Does anybody have any questions about that?
Yeah. Would you manually come up with the failed test cases, or is there a way to kind of I guess
Generate them?
auto-generate a bunch of failures?
Yeah, that's a good answer. There's some stuff in the AI realm today that can do some of this, like GitHub Copilot, for example. I know I showed GitHub Copilot before. If you start writing code in GitHub Copilot and you say, you start writing some of the cases, sometimes GitHub Copilot is smart enough to generate a bunch of the other cases for you. I haven't personally had much luck with GitHub Copilot getting it right, but it's getting there is kind of the answer. But as a programmer, we kind of think this way already. Like, for example, when we were working on that validate password function earlier, I think it's really natural as programmers to think in terms of cases where the code should do a thing and shouldn't do a thing. Like, as programmers, we learn about true, we learn about false, we learn about if, we learn about else. Like, after a while, those cases start to come on automatically. Is what I'm trying to say. Cypress is really cool. This is just scratching the surface of what it can do. It can do far more than just entering text into a box. It can click on things, it can scroll, it can pinch and zoom. It can navigate from page to page. It could do pretty much anything that you can do in a browser. You can script into Cypress. A lot of folks a lot of resellers, a lot of ticket scalpers, they use tools like this to automate and build robots to snag deals online. There's nothing that stops you from changing site.visit HTTPS localhost to ebay.com slash, some item ID. You can, this is just an automation framework. You can use these robots to do pretty much anything. This is more than just a testing framework. It's an entire automation framework for programmers. I think that's probably where I'm going to call it for tonight. Type, click, contains, those are some of the other functions. I'm not going to go into too much detail about what's happening around here with like the describe keyword and the it keyword. These are parts of the Cypress library. And so if you're interested in doing something like this for your capstone or for your personal projects, there's a certain amount of boilerplate and copy and pasting that you have to do. And so feel free to use this project as the starter for using Cypress or for writing those console asserts. But if you want to learn more about, okay, why do we have these two blocks, the describe and the edit block, I'm going to have to refer you to the Cypress website. Suffice to say, this is just kind of a way of organizing these tests. Describe and it, notice how the text here ends up showing up in this box over here. It's really just a way for you to structure these test cases. Okay, any questions? Other questions?
Yeah,
Is this, go ahead.
yeah, I got a question. Will it be possible for you to like share this code? Cause I got lost after like, I think like the first part of you trying to get the robot set up, I got
Yeah,
lost
absolutely.
doing that.
Yeah, absolutely. In fact, let me make sure. What's the workspace? Yeah, I'm doing this inside of here. Okay. In fact, robot code pushed. It's there for you if you'd like. Other questions, thoughts? I will also mention that there's some cases where testing is overkill. If you're working on some code and it's not doing a whole lot, I wouldn't reach for a test. There's situations where you're doing something with money. There's situations where you're doing something with passwords, where you're doing something that's complicated, where you've got 4 different return statements inside of a block of code, and you need to be able to understand, is this code working how it should? That's what I would reach for a test. Other questions or thoughts? Cool. That is all I've got for you tonight. Thank
I
you for
do
letting me
have a
come. Go ahead.
question. Sorry. So I wanted to save like my code on this project, and I wanted to make a fork, but I wasn't sure like, is the fork gonna like mess up something on your end, or is it just gonna be saved on mine as like a copy?
Saved on yours as a copy. Exactly.
Thanks.
Feel free to fork whatever you'd like to do. Cool. Well, thank you for letting me come tonight and talk about testing. This is one of those concepts that it's nice to have some exposure to. I also want you to think about. I know we're pretty early on in terms of having end-to-end functionality on the capstone working like from start to finish. But as you start doing repetitive things in your capstone, like for example, clicking from one page to another and checking it to make sure that the code that you're working on that changes some part of that capstone works. As you do that over and over and over again, and you do it for the 15th or the 16th or the 17th time, just think in the back of your mind, oh yeah, Nathan showed me something with robots that could do this in like 2 seconds if I just write a quick script. So have that in the back of your mind. And if you have any questions about Cypress, or you're just like, I think a robot would help me in terms of of testing my capstone, feel free to reach out. I'm happy to help you write some code to help you do this. Awesome. If there's no other questions, that's all I got for you tonight. The
Definitely
link to the
will.
slides, is here in chat. Mo, there is some links in the slides, especially on the last page. Specifically on the last page, it's mostly a reference for Cypress. But if you're interested in a tutorial from start to finish on using something like Cypress, I can find one and I'll post it. I will find one and I will post it in CIC C6 tonight. Cool. Thank y'all. Have a great rest of your evening, and I will see all of you for the DevOps week in the future sometime. Once you have your capstones ready to, well, after you get done learning Node.js and all that fun stuff, and databases, you got a bunch of really good stuff ahead. It was nice to see all of you again. Have a great rest of your evening, and see you in the future.
Thanks.
Peace out. Have a great night.
See ya.